Hi students, I welcome you all in the 10th lecture of the TOC, and in these lectures we are seeing how to design the PDA for the context-free languages. In yesterday's class we have seen some examples about how to construct a PDA for the languages. Similarly, we will focus on some more examples so that it will be easy for you to solve the new examples. Okay, so let's take this example. We have to design a PDA for the language. Language is given like p raised to power n, q raised to power n, r raised to power m, s raised to power m, where n comma m is greater than or equal to 1. So for this language, first of all we will write what are the strings possible over these languages. So the minimum length string will be p, q, r, s when n comma m is equal to 1. Also, when n is equal to 2 and m is equal to 1, the string becomes pp, qq, rs. Similarly, if p is equal to 3, n is equal to 3, then triple p, triple q, and when m is equal to 2, double r and double s will be there. So like this, we will get infinite number of strings in this particular language. Now for this language, we have to build a logic so that by using one stack we can able to design a PDA for this particular language. So we can see that whatever the number of p's will be in this language, that number of q's will occur because the power of both p and q are same, that is n. Similarly, whatever the number of r in the language will be equal to the s because both are having the same power. So we can say that we can compare p and q and similarly r and s. So for first p, when p occurs, we will try to push that p into the stack, and whenever q started occurring we will start popping. And similarly for r, whenever q is over and r started occurring, we will push r into the stack, and whenever s started occurring we will pop that particular r by using this particular s. Okay, so the now logic is clear. So let's try to design the PDA. So initially we are in q naught state and we are having, here I will draw the stack so that it will be easy for us. So bottom of the stack becomes z naught, and I will take this string, and after this string in PDA we have seen that the string always ends with epsilon, so I am adding epsilon here. Okay, now initially I am in q naught, and whenever p comes we have to push that p into the stack. So initially stack is having z naught, we can say that z naught is the bottom of the stack, and if after that input p started occurring, when p is input and stack contains z naught, then we have to push that p into the stack, so it will become p z naught. Once I have transferred that p into the stack, then I will update the top pointer. Now top pointer of the stack becomes this. Okay, so again for next p I will move to the next input, that is again p, and top of the stack is now p. So when input is p and top of the stack is p, then also I have to push the p into the stack, so it will become pp. Okay, and I will update the top pointer. After that, if q started occurring and we need to compare p with q, whenever p started occurring we will change that particular state and we will start popping. Okay, why we are going to change the state? Because if we will give the transition in same state, then problem is that after that there is a possibility to occur p in that particular string, and that should be not be accepted because we want language accept push down automata. So that's why we are changing the state. So q is the next input and p is the top of the stack, so I have to pop this. So for this particular q I have popped this P and I have updated the top pointer. Now top pointer becomes this, and now I am in Q1 state. And when I am Q1 state and I have updated the input, that input becomes Q and top of the stack is also P. So whenever Q is there and top of the stack is P, then also I have to pop the things. So here also I will do till the Q is occurring and top of the stack becomes P. Okay, so now P is removed from the stack and I have updated that top pointer, and now top pointer is pointing to the Z0, and similarly the next input is R. Now all the P's and Q's are over and R started occurring, and when R started occurring and top of the stack becomes Z0, then we have to push that particular R into the stack. So I will stay in particular state only, because when R started occurring and top of the stack is Z0, then only I am going to push the things into the stack. So here I have updated and I have pushed R into the stack. Suppose instead of this is the string, so next R is occurred. For this, when top of the stack becomes now R and input is also R, then I have to push that R into this particular stack. So this will become RR. So I have pushed that R into the particular this stack. Now for every R, whatever number of R's occur, I will use this particular step, and I will update the top pointer by inserting that particular R into the stack. Now suppose R over now S started occurring. Whenever S started occurring, we have to pop the things from the stack. So for this, input is S and top of the stack becomes R. I have to pop the things and I will change the state, because if I will stay in particular state, then again R may occur. So that's why we don't want R after S. So that's why we are changing the state, because it will accept. If we will stay in particular state, then there is a possibility to occur the strings like this: PP, QQ, RR, then S, again R, and we have to reject this string because our language doesn't contain this particular string. So that's why we are changing the state. Now we came to the Q2 state, and here also if we will got more S as input and we are having the R as the top of the stack, then also we will do the same transition, that is when when input is S and top of the stack is R, we have to pop that things. So I have popped that thing, and finally I have popped this R and I have updated my top pointer. Now top pointer becomes Z0, and here after the ending of the string there is a epsilon, and finally if I will get epsilon as input and top of the stack is Z0, I will keep that Z0 as it is and I will move to the final state, and I can say that the particular string is accepted by using this PDA, and we can say that this is the PDA for this particular language. Okay, let's see the another one. So the next question is like this: we have to design a PDA for the language P to the power n, Q to the power m, R to the power m, and S to the power m. Okay, so now we will check Q and R we can compare, and similarly P and S we have to compare. Now for P, whenever P started occurring, we will push that P into the stack. Whenever Q started occurring, then we will push that Q into the stack, and when R started occurring, we will pop, because we have to compare these. So for R we will start popping, and for these S should be compared with this P. So when S started occurring, we will pop this P. Okay, so बेसिकली अगर हम इसके लिए अगर लैंग्वेज लिखेंगे तो लैंग्वेज कैसे आएंगी? लैंग्वेज कंटेन्स द स्ट्रिंग्स लाइक when n is equal to 1 and m is equal to 1, the minimum length string should be pqrs. When n is equal to 2, then string becomes pp, and m is equal to 1, then qr, and this is ss, because n is equal to 2 is there. When n is equal to 3 and m is equal to 2, then string will be like this. Okay, and the language contain infinite number of strings of this pattern. Okay, now for this we need an stack. So we have taking one stack here, and stack contains initially z0 as a bottom of the stack, and we are taking the string for solving this particular or for designing this particular PDA, that is triple P Q Q R R triple S. Okay, and finally we are adding epsilon. Now I am here, and top of the stack becomes z0, that is stack alphabet. Now initially I am in Q naught state, and whenever P is occurring, we have to push that P into the particular stack. So P started occurring because first input is P and top of the stack is z0. So here I will write P and top of the stack is z0. I have to push that particular P into the stack, so it will become P z0, and I will update the top of the stack. And similarly I will move to the next input. Next input is again P, so P and top of the stack is P, top of the stack is P, so I have to insert that next P into the stack, and I have to update the top pointer. So top pointer becomes this, and I will scan the next input. So next input is also P and top of the stack is P, so we have transition for that. P is the input and P is the top of the stack. Then we have to update the stack by pushing that P into the stack. So I am pushing that P into the stack, and I have updated the top pointer. Now next input is Q, and for Q also we have to push it into the stack. Whenever we will push the Q, definitely the stack pointer is having topmost alphabet as P only, because m, n is greater than or equal to 1. Minimum P कितनी हो सकते हैं इसमें? 1 definitely will be there when Q started occurring. तो अगर Q started occurring and top of the stack क्या होगा? हमेशा P होगा. ऐसा नहीं है कि z0 मिलेगा. This is not possible in this particular case because m, n is greater than or equal to 1 है. So for this we will write transition within the same state only, because it will not create a problem, because whenever the input Q comes, definitely there will be a top of the stack is P only. So when Q is the input and top of the stack is P, so I have to insert that Q into the particular stack, so it will become QP. I will update the top pointer as Q. So next, whenever next Q occurs, then top of the pointer becomes at Q. So top symbol contains Q only. So Q is the input and top of the stack is Q. Then also I have to insert that particular Q into the stack. So now I am here. Now Q's are over and R started occurring. Whenever first R start occurring, then what I will do? I have to pop that particular Q with respect to that particular R, and I have to move the state. I have to move to the next state, because if I will stay in that state only, then problem will occur. We have seen what type of problems we have gone through. Okay, so that's why we have changed the state, and when top of the stack is R, sorry, input alphabet is R and top of the stack is Q, then I have to pop that. So I have popped this Q for this particular R, and I have moved my top pointer here. Now I have moved to the next input, that is become R only, and I am in particular state Q1, and top of the stack is Q. So here I will write like this: when R is there in input and Q is the top of the stack, then I will start popping. So I have popped this Q also, and I have updated the top pointer here. Now next input is S and top pointer is P, definitely, because we have to match p is with yes only. Okay, so when yes is the input and top of the pointer is p, then also we have to pop. So we will stay in particular state only, because this will not create any problem, because for popping p we definitely need a yes only. So yes is the input and top of the pointer is, top of the stack is p, so I have to pop. So for this yes I have popped this one, and then I move to the next input and top of the pointer is p, then again I will use same transition. For this yes also I will use this transition. Now I have moved, top of the stack becomes z0 and input is epsilon. So input is epsilon and top of the stack is z0. Then I will keep that z0 as it is, and I will move to the QWave state, that is the final state. And by reaching final state, I can say that this particular PDA will accept the strings like this. Okay, so this is the PDA for particular this language. Okay, आई होप आप लोगों को समझ में आ रहा होगा ये. ओके, जितने ज़्यादा हम क्वेश्चन सॉल्व करेंगे उतना ज़्यादा हमारा अंडरस्टैंडिंग लेवल बढ़ जाएगा इसमें. ओके, सो लेट्स टेक अनदर वन. So next question is this one, and this is a very interesting one. So let's try to solve this. We will first build a logic for this. So question is that we have to design a PDA for the language L is equal to p raised to power n and q raised to power 2n when n is greater than or equal to 1. First of all, we will identify the strings present in particular language. So minimum length string will become this one, p and pqq. Okay, this is the first string. Then when n is equal to 2, the string becomes pp and this will become qqqqq. Okay, when p is equal to 3, the string becomes, okay, so whatever number of p comes, if we will double that, then that number of q's will be present in particular string. So the language contains such type of strings, and the language is infinite because the language contains infinite number of strings. So first we have to build a logic for this. So this question can be solved, or we can say that the PDA for this question will be designed in two ways. First, we will do in such a way that whenever p started occurring, okay, whenever p started occurring, we will push, but when single p started occurring, instead of pushing one p into the stack, we will push two p's for single occurrence of p. Okay, मतलब क्या करेंगे हम, जब भी सिंगल पी ऑकर होगा उसके जगह पे हम क्या करेंगे, टू पीस स्टैक में पुश करेंगे. अब तक हम क्या कर रहे थे, अगर पी ऑकर हो रहा है तो सिंगल पी ही हम स्टैक में पुश कर रहे थे, लेकिन अब यहाँ पे क्या करेंगे, एक पी ऑकर हुआ तो दो पीस स्टैक में इंसर्ट करेंगे. ओके, सो फॉर सिंगल ऑकरेंस ऑफ पी वी विल पुश टू पीस इन द स्टैक. ओके, सो लेट्स ट्राई टू सॉल्व दिस. I'm taking the stack for this, and this stack is having bottom of the stack, that is z0, and I will use p p q q q q q. This is the string, and finally this string is ending with epsilon, and my input pointer is here, and initially I'm in q0 state. Just a second. Initially I'm in q0 state. This is initial state. Okay, so first input is p, and for p I have to push. Whenever p comes, I have to push into the stack, and for single p I have to push two p's. So when input is p and top pointer of the stack, top alphabet, we can say that is z0, then I have to push two p's. So this is first p, this is second p, and this z0 as it is. So for single occurrence of p, I am pushing two p's into the stack, and I have updated the top pointer. Again, next p occurred, and for this P also I have to push 2 P's. So this P occurred, P as input, and top of the stack is now P only. So I have to push 2 P's and this third P as it is. So total 3 P's. Okay, 1, 2, 3. I have updated top pointer. Now I am in I have the input Q and top of the stack is P. So whenever Q started occurring, I have to pop the P and I will change the state. So because I am changing the state because after Q I don't want P, because the language doesn't contain the strings like this. The language contains definitely P first and after that Q. So whenever input is Q and top of the stack is P, I have to pop that. So for this Q I have popped this P and I have updated the top of the stack, top point. Okay, now I am in Q1 state, and when in Q1 state, I am in Q1 state and I have seen Q as an input and top of the stack is P, then for that also I have to do the same step, that is Q is the input and top of the stack is P. I have to pop it. So for this Q I have popped this P, for this particular Q I have popped this P, and for this Q this P. Now stack contains nothing except that Z0 and I am left with only epsilon as an input. So whenever such type of things occurs, means epsilon is the input and top of the stack is Z0, I will keep that Z0 as it is and I will move to the final state, that is QF state. So this is the QF state, and after reaching that state we can say that this particular string is accepted by this PDA, or we can say that for this particular language this is the PDA, which is a language accept. Okay, so let's see the another way of solving this. So let's see the another way for this particular question only. So in previous way we have seen that for for single P, whenever single P occurred we have pushed 2 P's in the stack. Now what we will do, instead of doing that, when P comes we will push that particular P into the stack, and whenever Q started occurring, what we will do, first Q we will left as it is, we will just read that, and whenever second Q occurred we will pop particular P from the stack. Means we can say that for odd number of P's we will just read it, and for even number of P's for even number of for odd number of Q's we will read it, we will not do any operation, and for even number of Q we will pop one P from the stack. Okay, so let's do in that way. So here I am taking the stack for better understanding. So this is the stack and bottom of the stack is Z0, and string I will taking so P P Q Q Q Q, and this is epsilon, and initially I am in Q0. When I am in Q0 and top of the stack is Z0 and my input is P, then I will do this operation. When P is the input and top of the stack is Z0, I will push that P into the stack. So I have pushed that P into the stack and I have updated the top of the stack becomes now this one P. And after processing this P, I will move to the next input, that is also P, and top of the stack is now P. So P is the input, top of the stack is P. Then again I will push that particular P into the stack, and after pushing I will update it, and then I am pushing that particular P into the stack. Now after P is processed I will move further. The next input is Q. Whenever Q is occurred. Now this particular queue is occurred first time. So for first time, whenever queue is occurred, I will take that queue as input, and top of the stack is P. I will not do any operation. I will just read it. Means I will make that P as it is. I will left that P as it is. I will not do anything. Okay, and I will move to the Q1 state. Now when I am Q1 state, and now top of the stack is P only, and I have got second queue. For second queue, what I will do, for this queue and top of the stack is P, I will pop it. Okay, and I will move to the next state, that is Q2. Now again third time queue is occurring, I have to just read it. I don't want any operation for this particular queue. For this particular queue, we have popped this P and we have updated top pointer becomes this one. Now for this queue, we want it to just read. So what I will do, I will not take another state, or I will not move to the another state. I will use this state only. So whenever third time queue occurred, I will move to the back state. So the transition become for this Q, top of the stack is P. I will not do any operation. I will make as it is that P into the stack. So this is the first time occurrence of Q. This is the second time, and we can say that this is the third time of occurrence of Q. Okay. Now third time occurred. When fourth time Q will occur, I will move to that particular this state and I will do this operation. So I will do this popping and I will update the top of the stack. Whenever now fifth time Q occurred, I will go to this particular state because I am left that P as it is, because for odd number of things we don't want to the pop that particular P from the stack. Whenever even number of Qs occurred, then only I will do the popping. So by this way we can do the popping. Okay, and finally when nothing is left in the input, that is epsilon only, and top of the stack is now Z0. So epsilon and top of the stack is Z0. I will make that as it is. I will not do any operation. I will left that as it is Z0, and I have moved to the final state, that is QF. And we can say that for this particular language, that is P raised to n and Q raised to power 2n, where n is greater or equal to 1, this is the PDA, or we can say that this is the PDA. Both way are correct only. Okay, so this string is accepted by this PDA also and this PDA also. Okay, so this is the PDA for this particular image. Okay, so let's see the another example. So we have to design a PDA for the language. Language is given like this: W, C, W reverse, where W belongs to the A comma B closure. Okay, so we are using closure because we have to say that W is greater than or equal to 1. Okay, that should not be 0. R is not removal. Just second. R means a reversal. Okay, so this R is reversal of the string. Suppose we will take W as, that is the combination of A and B. So I have taken W as ABB. Then W reversal of this will be BBA. We have to take the reverse of this particular string W. Okay, so we can say that, suppose I will write this language or write string in terms of this, then string becomes ABB CBBA. So if I will read from this side or this side, I will get the same string. Okay, ABB CBBA, ABB CBBA. Okay, So I can say that the language contains the strings of, we can say, the odd number of palindromes, because of this C we will get always odd number of palindrome strings present in this particular language. Now we have to make a logic for this. We have a stack with us which is having Z0 as the bottom of the stack, and we have W and W reversal. Whenever W comes, we have to take W reversal, and C is there to understand that W is over. We can easily say that by this example whether W reverse started or not started by seeing this particular C. Whenever we will get C, we will change the state and we can say that okay, now W is over and it's time for W reversal string. Now if we will carefully observe this, suppose this is my stack, okay, and stack contains Z0, and I have pushed this A, B and B into the stack. Now C is there. For C, I will just read it and I will move to the next state. Whenever B started occurring, what I will do? I have to compare this B with this. Okay, this B with this B, this A with this A, and finally I will left with Z0. So basically, I can say that this B is compared with this B, this B is compared with this B, and this finally this A is compared with this A. Okay, so till W is there, we have to push whether it is A or B, we will don't care it, just we have to push till C occurs. Okay, whatever the top of the stack or whatever the input is there, we have to push into the stack till C occurs. Okay, so my first state, that is Q0, which is initial, and if I will get, suppose, string like this A B B A as a W string, so for this I will write the possible number of transactions. So initially stack contains Z0 and top of the stack is now A, sorry, input is A and initially I am with Z0, so I will put, or I will push that A into the stack, so stack becomes A Z0 and top of the stack is this one. Next I am with B, means B is the input and top of the stack is A, then I have to push that B into the stack, so this will become BA. So this is the top of the stack and this is become BA. Similarly, now top of the stack is B and input is also B, so top of the stack is B and input is also B, so I have to push that B into the stack, so this will become B. Now I am left with A and top of the stack is B, so I will write here A and top of the stack is B, then also I have to push A into the stack, so this is become A, and I have moved the top pointer, top of the stack now to this, so top of the stack is now A. And suppose let's take another string, the string is become like W is equal to B A A B, and finally this is the epsilon. Now initially B is there and stack contains nothing in the stack, that is Z0, so I have to push, so B is the input and top of the stack is Z0, I will push that B into the stack. Similarly, now A is there and top of the stack is B, I have to push that B into the, sorry, this A into the stack. By using this operation this can be done. Now top of the stack is A and my input is also A, so I have to push this particular A into the stack, but there is no transition available, so I will create one transition like this. A is the input and A is the top of the stack, so I have to push that particular A into the stack, so These are the possible operations. And again, now top of the stack is A and B is the input. So top of the stack is A and B is the input. B is the input and top of the stack is A. I have to push particular B into the stack. So by using this operation we can do this one. Okay, so I think all the operations came in this. And finally, if we will get the string like this, suppose W is equal to ABB and now C occurred. So I will cut this A and ABB. This is the same. And C occurred. Whenever C occurred, what I will do? When input is C and top of the stack is, now in this case B is there, I will left that as it is B only and I will move to the next state Q1. But what if when C occurred and suppose my W becomes BAA, in this case my top of the stack is A and suddenly C occurred, then C is the input and top of the stack is A. I will left that A as it is and I will move to the next state. Okay, so this is the two transitions available to move to the next state. Okay, now C is occurred and we definitely know that from this onwards we have to start popping because W reversal is started. So now B is the input and my top pointer pointing here. When B is matching with this B, top of the pointer, then we will start popping. When B is the input and top of the stack is B, I will do the popping. So I have popped that B for this particular B. Next, I have popped this and I have updated the top pointer. So top pointer is B and my input is now also B. So by using this operation, I can pop this particular B for this particular B input. And I have updated the top pointer now moved to the next input, that is A. So A is the input and top of the stack is A. There is no transition available, so I will make a transition whenever A is the input and A is the top of the stack. I have to start popping. So A and top of the stack is A. I have popped it and I have moved the top pointer to Z0. And whenever I left with Z0 and top input is epsilon, then I will left that Z0 as it is and I will move to the final state, that is QF. After reaching that state, we can say that particular this string is accepted by using this particular PDA. Okay, so this is the PDA for this particular language. In this PDA, we have observed that we are doing popping for A also and B also whenever the input is matching with the top of the stack, then only we can pop, otherwise we will not able to pop the things. Okay, I hope आप लोगों को ये समझ में आ गया होगा. Okay, so I will give 2 questions as a homework to you. Please do that, try to do that so that you will get an idea. So the questions are like this. So first question is that we have to design a PDA for the language. So language is become p raised to power n and q raised to power 2n plus 1. So we have already seen an example, or we have already designed a PDA for a language p raised to power n q raised to power 2n where n is greater than or equal to 1. Here only difference is that we have one extra n, so you can easily solve this example by referring the previous example. Okay, also try to design a PDA for the language p raised to power n, q raised to power m, r raised to power n, s raised to power m, where m comma n is greater than or equal to 1. So I request you carefully observe this question and try to design a PDA for this particular language. Okay, so in next lecture I will explain how to solve these examples, but before that I request you to go through it and try to solve these examples. I hope आप लोगों को ये वीडियोस पसंद आ रहे होंगे. एंड प्लीज अगर आपको कोई भी क्वेरी आ रही है तो प्लीज रेफर ए टेलीग्राम ग्रुप, और you can comment in the comment section so that we can easily trace that and we will able to reach you. Okay, thank you so much. We will meet in the next lecture.